Okay, great. Well, thank you, Eric, and everybody for the invitation to present to this group. I'm a professor at Scripps Institution of Oceanography. I'm a coastal physico-oceanographer by training, but I've been doing a lot of work in the San Diego-Mexico border region, studying various things like rip currents and then dye transport and dilution. So what you can see here in this photo, we released some dye. You can see these rip current heads drawing this dye-rich water out of the surf zone. There's also a south swell at the time that's bringing the water up. Sort of like, spent a lot of time for the past 15 years studying the hydrodynamics of this. But as I'm sure most of you know, that this region at the San Diego-Tijuana border region is one of the sort of like ground zero spots for raw sewage entering into the ocean and having impacts. And so that then led to sort of like more interest in seeing how we could model this. And so I'm going to talk to you and tell you guys about a recent paper that I published along with some colleagues in the journal AGU GeoHealth last year. Okay, so I've also given this talk to different sorts of stakeholder groups that have different sort of like awareness of the situation. I'm just going to assume that there may be things that you guys already know, and so just bear with me, right? But one of the things is that there is, to this border region, there's significant raw wastewater input into the region. It has significant economic and health impacts to the local communities. Okay, as a result of that, in 2019, this Mexico-Canada trade agreement was passed, and as part of that, there was a lot of money allocated to border water infrastructure projects. And the EPA was going to, their border water infrastructure program is going to try and figure out what kind of infrastructure projects to develop so that we reduce the amount of raw sewage that enters into the ocean. The EPA gets to decide, but really the immediate question that came up is, well, what infrastructure projects would give the best benefit? And that's either in terms of reduced swimmer illness or reduced numbers of beach closures. Okay, so the strategy, what we did, essentially the strategy was to use ocean numerical models that are that basically simulate the flow of water in the ocean and the mixing. These models are analogous to weather models, and then we couple them to human illness models, or you guys may be more familiar with QMRA, quantitative microbial risk assessment models, that folks like Ali Baim, one of our collaborators, have been very much behind. And we can evaluate the sewage effects on swimmer health, and then evaluate potential infrastructure scenarios in terms of improving swimmer health. Okay. So the outline here is I'm going to tell you a little bit about the regional sewage sources, impacts, and testing. Some of this may be familiar to some of you not. I'm going to show you some example simulated sewage events. I'm going to talk about the impacts for business as usual, so that means no change to what's going on. We're going to simulate the year 17. Talk about the infrastructure scenarios considered, and then how we evaluate them in terms of reduction of beach closures, and then the impact of this work in the future. Okay, so let's just get started. There's two gigantic sources of sewage that get to the ocean. One is the Tijuana River Estuary, or the TJRE. This is the entire region. This is the U.S.-Mexico border. The city of Imperial Beach is located here. Playas Tijuana is located here. And this is the Tijuana River Estuary. And the Tijuana River enters the estuary approximately where the star is located. And the other source is Punta Bandera, where the San Antonio de los Buenos outfall essentially dumps 35 million gallons a day of raw sewage right onto the beach. And so just to give a little bit more context, here's the Tijuana River Estuary. Now, for aerial photo looking south, this is Playas Tijuana on the other side of the U.S.-Mexico border. This is a view looking towards the north. This is San Diego Bay. City of San Diego is in the distance. And on this day, you can see this brown water is coming out of the estuary and making a big plume here with a front up there. These are sort of like the physical oceanographic things that I nerd out on. And then it's important to note that this brown water is brown because of sediment, but surely it's highly contaminated with lots and lots of pathogens. Okay, under normal conditions, the untreated wastewater really only enters the estuary when it rains. And by normal conditions, I mean, hey, the infrastructure in Tijuana and the infrastructure that's been developed with the International Boundary Water Commission is working. Now, that's not happening nearly as much now as it was in the past. But that's the situation when it's under normal conditions. When it rains, by treaty, the Mexican authorities basically can turn off the pumping system, and because they're afraid that their pumps are going to get contaminated with trash, and then the river starts flowing, and what happens there is that it's both rain runoff but also raw sewage. And estimates based on sort of like an accounting of how much sewage is in the Tijuana system estimates that's an upper limit of 10 million gallons a day, which is a lot. And then what we did here is we did not consider catastrophic infrastructure failure. And some of you may be familiar, in November of 2019, basically the diversion systems in place in Tijuana basically stopped working, and they stopped working all the way through the summer of 2020. And so that was basically the river was flowing all the time with raw sewage, and that's obviously really bad. We did not consider that. Okay, this is a video. So now we're going to focus in on Punta Bandera, which is located 6 miles south of the border and 9 miles from Imperial Beach. This is a YouTube video from the Surfrider Foundation, and this is raw sewage, untreated sewage, just flowing right down onto the beach. And historically, this has been neglected in considering sort of like U.S. swimmer illness risk. And, you know, in working down in IB, you know, the mayor and lifeguards and surfers and stakeholders would always ask me, look, can the water from Punta Bandera make it north all the way to IB? And this is because, hey, I'm surfing or I'm swimming and the water tastes like poop and laundry detergent at the same time. And can it make it north? And I was just like, it could, but I can't, you know, I couldn't quantify it at the time. Okay. Oh yeah, 15 kilometers, that's 9 miles in U.S. thing. Okay, so there's large impacts to border coastal community health and economies from this. This is an article from the Union Tribune here, and in 2020, the Imperial Beach shoreline was closed for 295 days. This is largely because of the, you know, or in good part because of that catastrophic infrastructure failure. Oh, this is near the international border. This is the IB pier. It was closed 50% of the time. So that's obviously really bad. Now, we have to think about what is driving these plumes of pollution. And basically, a lot of it is transported in the surf zone, so just within a few hundred meters of shore. And that transport depends on the waves and on the wave angle. And so here in this photograph of a dye plume that we released it around where the star is located, and the dye is just going to the north at about 20, 30 centimeters a second. And the reason it's doing that is because this is in September during a time of south swell, where the waves are coming out of the direction of the southwest. And that drives currents along the coast to the north. If the waves were coming from the other direction, it would drive currents to the south. And what happens in our part of the world here is that in the summertime, it storms, because it's wintertime in the southern hemisphere, the storms between New Zealand, Chile, and Antarctica make gigantic waves down here, and those waves propagate as swell all the way across and are surfed by surfers in the summertime here in California. That tends to drive the currents to the north. And you can see that if you're standing on the beach or swimming at the beach during one of these south swells and you just sort of like bob and float, you're just going to get drifted. You're just going to get slowly drifted to the north. In the wintertime, of course, those swells come from the northwest, and so the currents preferentially go to the south. Although you can have south swells during the winter and you can have northwest swells during the summer, but it's just which is more prevalent. Okay, so what we do is we simulate the year 2017, the raw sewage plumes with an ocean model that includes, and this is the novel thing, it includes the surf zone, it includes the shelf, the region out here, and it includes the estuaries and the San Diego Bay as well. Okay, now One thing that I want to bring up is sort of like issues with current beach monitoring efforts, right? So, the previous speaker, talking about his system or their system basically gives you these real-time measurements, right? And so everyone knows that, like, you take a water sample, you want to culture the fecal indicator bacteria, you got to go back to the lab, and then it takes time, and then you may close the beach, but the beach may no longer be contaminated, right? So it's much better to have real-time data. But there's something that's really important, right? Is that swimmer illness is that due to swimming in raw sewage is dominated from norovirus. And fecal indicator bacteria only indicate a fecal source, but fecal indicator bacteria die in sunlight with a relatively short half-life. 8 hours is a very conservative value. Norovirus, in contrast, has a 14-day half-life in the ocean. So the fecal indicator bacteria could be exposed to sunlight because they're gut bacteria. They don't have any protection against sunlight. They die, but the norovirus is still hanging around, right? And we're not sampling for norovirus. And so we're going to see sort of like the effects of that. Okay, so here's some examples from the modeling of the year 2017. This is a big winter event. The details of the hydrodynamic models are described in a series of papers from a former postdoc. And here's a big wintertime event. So again, the U.S.-Mexico border, the city of IB, San Diego Bay, and this plume here spans both the surf zone and the shelf. And this represents the fraction of raw sewage. And that the color bar here is in scientific notation and is set up. Qualitatively, this looks like a little bit like this plume coming out of the estuary. This is from the estuary. And 10 to the minus 3 is a 1 in 1,000 dilution. So basically what I tell people is that this means that you take 1 milliliter of water with a syringe of raw sewage, you put it in a 1 liter bottle, you close it, you fill the rest of the bottle up with clean water, and that's what you or your kids are going bathing in, right? And clearly through much of this region here, the concentration value is greater than 10 to the minus 3. Okay. Now, we also have a big summertime event where the source is the San Antonio de los Buenos outfall at Punta Bandera, and this is a time of a long-lived south swell in conjunction with winds that come out of the south, and you can see how strong the concentrations of raw sewage are, in some cases 10 to the minus 2. And this is coming from that source there. And so what I want to do next is I want to just show you a video of this slide. All right. So this is a video that I have on YouTube, and I'm happy to share the link. And it's not showing. Why it's not moving. So here we'll just keep an eye on this. So in a second, the swell is going to change direction, and we're going to see the entire bite just basically getting filled with dye. And again, this is the fraction of raw sewage. So this video runs for the entire year. It's fun to look at, and I'll put it in the chat. I'll put it in the chat later. Okay, let's go back to the presentation. Okay, so business as usual. We're going to model now swimmer illness using due to norovirus. I have to say that sometimes it's not norovirus is not COVID-19. It's plentiful in raw sewage and it dominates swimmer illness risk. It's not tested for in beach water sampling. Its symptoms are gastrointestinal illness, which is very common, so both throwing up and diarrhea at the same time, and then fevers and aches, which is less common. We know how much, on an average in the distribution of norovirus in raw sewage. And we can model it using these QMRA models for the year 2017. Okay, so first what we did is we got beach visitor and swimmer data from the city of Imperial Beach, averaged it over 5 years, and they gave us monthly data. And what you can see is that in the month of July, there is a lot of, that's when most people are at the beach. And then in January and February, there's very few people at the beach, right? So this sort of makes sense. And then what we're plotting below, this is the number of swimmers per hour, so at up to 300 swimmers per hour. And in January, February, 20 swimmers per hour. So these are the surfers here. What we're now plotting in panel below is the number of ill swimmers per hour. So again, you can see the summertime has heightened number of ill swimmers, and you can see these peaks coming up. These peaks correspond to the south swell pollution plumes that are getting ejected up from Bandera, and you can get easily well over 30 swimmers per hour becoming sick. In contrast, in January and February, when there's less swimmers and there's less, overall, you're getting much less people getting sick. And over the entire year, there's 864,000 yearly swimmers. 34,000 of them, about 4%, become sick from norovirus, according to the model. Okay? And so we can also then estimate the percentage of time the beach should be closed from norovirus, or at least be under advisory. Now, EPA guidelines say that a beach should be under advisory if more than 3.2% of the swimmers would get sick. And this value is what's used to set the levels of various types of pathogens. Right? So using that metric, we can ask then how often should the beach be closed at a number of different beach locations. And so over here on this x-axis, on the plot, I've shown Playas Tijuana, 4 beach locations: Playas Tijuana, Imperial Beach, Silver Strand, and the Hotel del Coronado. Okay, the source of Punta Bandera is located here. Tijuana River Estuary is located here. Showing Playas, Imperial Beach, Silver Strand, Hotel del Coronado. Percentage of time the beach should be closed. And then we're showing it for the full year, the wet season, which is October 1 to April 1, and then the tourist season, which is essentially Memorial Day to Labor Day, the earliest Memorial Day to the latest Labor Day. Okay, so let's just focus on Imperial Beach, right? Over the full year, the beach model says the beach should be closed like 37% of the time. In the wet season, a little bit less, maybe 36% of the time. But in the summertime, interestingly enough, it's about 44% of the time. And this is due to the south swell plumes from Punta Bandera. As you go from south to north, there's a clear pattern of Playas Tijuana is the most impacted, Hotel del Coronado is the least impacted. But it still has pretty significant impacts from norovirus, at least according to our model. And this is essentially because the hydrodynamic dilution is relatively weak, and norovirus lives for a very long time. Okay, so the impacts do lessen to the north, and Punta Bandera gives the largest impacts. And we can tell that basically because in the tourist season, there's higher levels of fraction of numbers of times that the beach should be closed. All right, so this coupling of the hydrodynamic model and the QMRA models gives us a method for determining illness rates in beach closures. And it also allows us then to determine the benefits of different sorts of infrastructure projects. Okay, so for the USMCA decision-making that's being done by the EPA Border Water Infrastructure Program, they considered 10 potential projects. And what we did is we simulated 3 projects, because you need a supercomputer to do all this. We simulated 3 projects that sort of like were a combination of these 10 projects. So I'm going to summarize them here. Scenario A includes diverting the TJRE inflow up to 35 million gallons per day. That means if the flow into the estuary is less than 35 million gallons a day, it gets diverted to some magical treatment plant and goes out of the system. But if it's above 35 million gallons a day, it flows into the estuary. The other scenario, and then secondarily, we reduce the flow at Punta Bandera to 10 million gallons a day of treated wastewater. Treated wastewater has 5% of the norovirus load of untreated wastewater. Okay, scenario B doesn't do anything in Punta Bandera, but it diverts the TJRE inflow up to 100 million gallons a day. So if it goes above 100 million gallons a day, it flows in, but otherwise it'll be diverted. Scenario C is similar to B, but now we're at 163 million gallons a day. This quantity was chosen, 163 upper limit, is based on there's a South Bay Ocean outfall pipe to the South Bay Ocean outfall, which is about 3 miles offshore in about 100 feet of water depth. And that's where some of this diverted flows are expected to go. But that's sort of like the excess capacity that would be in that pipe. Okay, so we use the model to calculate the percentage of time the beach should be closed from norovirus. So again, just a reminder what those 3 scenarios are. And so what I'm showing you now here is for the full year, again, Playas Tijuana to Hotel del Coronado. Now the colors represent the baseline scenario, which I already showed you, scenario A, scenario B, and scenario C. So let's focus again on Imperial Beach. The baseline, it was about 37% the time that the beach should be closed. Under scenario A, we've reduced it to like 12, 13%. The time the beach should be closed. But scenario B and C, which only affect flows going into the Tijuana River estuary, there is some reduction, but the reduction is not as great as with scenario A. And in addition, you don't really get any additional benefits from doing 163 million gallon a day diversion relative to 100 million gallon a day diversion. So at Imperial Beach, scenario A is the best. But now if you look across all locations, scenario A is the best in all of them, and scenario C doesn't really get you much for all that increase in diversion capacity. Okay, so I just said these things. And so the result of this study is basically that fixing all the raw sewage that's flowing in from the San Antonio de los Buenos plant at Punta Bandera gives the greatest benefits. Okay, so here is the title page of our paper. It's gotten a little bit of attention. There's an article in the Union Tribune. I liked how they framed this because basically it was the surfers and the lifeguards that basically turned us on to this. KPBS, the local public radio station, also did a story. The importance of Punta Bandera is increasingly being recognized due to this work. Okay, this work has also influenced the decision making by the EPA's Border Water Infrastructure Program. There's another Union Tribune article. The amount of money that's being expected to be allocated with the Biden infrastructure program has now increased substantially. And Lily Lee, who's the manager of the EPA Region 9 Water Structure Infrastructure Office, had a nice quote about the study. Okay, so now we're not done. There's something we'd like to do next, which is basically we ran the model in hindcast mode, and that means that we ran the past, and that's significantly easier to do than to model sort of like real time what's going on right now, or even to forecast. But what we'd like to do is we'd like to turn this into a forecast model for human illness risk in the U.S.-Mexico border region. And the concept really is to allow a family to say who lives in Chula Vista, which is a coastal or a community at about right here where my mouse is, whether they can take their kids to the beach on the weekend. And basically the idea would be to combine pathogen ecology and hydrodynamic models in forecast mode. We would be leveraging significant previous investment. We'd provide regional 3 to 5 day forecasts, and it would also be interdisciplinary because we'd involve microbiologists and things. We'd make a lot of measurements and stuff. So this is something that's currently being considered under the state of California has allocated money to sort of like a border river program, and Cal EPA and the Water Board is in part evaluating this proposal of ours. All right, that's it. Any questions?
Thank you, Falk. Folks, you can ask your question by unmuting. You can raise your hand. Also, send questions via the chat. Okay, Terry? You have a question?
In the old days, what San Diego had is they had the HF radar out there, and basically, they would put a sign up whenever the south swell was happening, because I suppose the south swell isn't a continuous thing, right? And so
No, it's not. It's definitely not a continuous thing. So there's a problem with HF radars, which is that, and the problem with the HF radars, there's three problems. One, they don't make any measurements close to shore. And the second one is that it's often gappy. And, and then the third one is it's noisy. There's a significant amount of noise. So there is this plume tracker that's on the SCOO's website, but it is it's often quite erroneous. And so if you look at a map, like for example on this map, I have another slide which I'd have to find, but like the HF radar currents are empty in like anywhere onshore of, let's say, this 30-meter isobath here. So you can't model what's going on here with the HF radar currents.
but could that be solved by the addition of an HF radar in that area?
You'd have to, I don't know all about all the technical details with HF radar, but I do believe that they have significant amounts of blanking distances. So that means that they can only make a measurement at a certain distance far away, depending on their, because they're measuring Doppler shifts, and so you don't get a return within a certain range.
Okay, thank you. I appreciate the presentation you give, and I work with Doug Leiden, so.
Oh, yeah. No, Doug was an integral part of this.
Yeah.
Hal, you have a question?
Yes, thanks. Yeah, interesting project. Has there been any progress in getting Mexico and Tijuana to treat that wastewater before it goes? Or I don't know, it seems like getting it at the source can maybe eliminate a lot of issues.
Yes. So I think the I've given a presentation similar to this to the IBWC Minute 320 working group in Tijuana, and so they're aware of it. And one of the things, from what I understand, what the Border Water Infrastructure Program wants to do is they want to prevent the water. They take the water, and what Mexico does is they pump it up this gigantic hill to the top of a mesa where the San Antonio de los Buenos treatment plant is located. But the treatment plant is a misnomer because it doesn't do any treatment. It just bypasses and then flows it straight down the river, straight down the creek to the ocean. They want to take it and basically reroute it so that it goes into a new sort of system and comes across the border, and they're going to refurbish the South Bay International Treatment Plant. It's from what I understand, so that it's going to prevent a lot of this. It's going to prevent the issues of it's going to ameliorate the issues of Punta Bandera.
Thanks. That's strange. Cool.
Luke, you have a question for Falk?
Yeah, great presentation. That was really informative. Thank you for that. And what you just mentioned actually brought up another question, but I think you could answer all of them together. So just wanted you to reaffirm that you said something earlier that sewage really only flows out of the river estuary when it rains, unless there have been those infrastructure failures. Is that correct?
Yes.
Okay. And you mentioned the one in 2019, and I believe we just had one. So unfortunately, those occur pretty frequently. Okay. Yeah. And could you just explain a little bit more about that infrastructure project for improving Punta Bandera? Isn't that pretty far south on the coast?
It's 6 miles south
of the city,
it's 6 miles south of the border, right? The border is located about right here. That's the border fence right there, if you can see my mouse. So it's located 6 miles south of the border.
Okay. So they were going to, what are they going to do? How are they going to?
No, I'm sort of speaking a little bit out of I'm not prepared on this, so like, I've been told, but I don't remember exactly. So, but like what they're going to do is they're going to prevent, so there's a pipe somewhere around here that pumps the water up this hill on top of this mesa. And what they're going to do is instead of having them pipe that water up or pump that water up, they're going to take it over and bring it across the border and then refurbish the South Bay water treatment plant.
Okay.
And so the South Bay water treatment plant is a decommissioned plant that's no longer in use, and they're going to do that and then pump things out at the South Bay ocean outfall.
Gotcha. Okay. So yeah, it sounds like they're not going to use those holding ponds anymore then, which are down there somewhere.
Up at San Antonio Los Buenos? No. That's the whole idea.
Okay, great. That's what I was looking for.
Yeah.
Thanks.
Yeah.
We have 2 more people in the queue with questions.
Okay.
First up is Dan.
Thank you very much. A great presentation, and it ties in nicely with some of the things I presented just earlier, specifically the work we did with the California Water Quality Control Board. They were testing the alert system in the Tijuana River precisely for this kind of issue, all the water that comes, raw sewage essentially that comes from all the side canyons. So one of the questions, would it help to be able to have a source term, to be able to measure in addition to flow, to also measure, let's say, the E. coli content, which you could correlate to norovirus present at the source, so, in the Tijuana River, so that would that help to feed back into your models to get more accurate, predictions of water quality?
I think undoubtedly it would help. I don't know how much it would help. So the thing is that the stuff that's coming into the Tijuana River estuary in the Tijuana River is pretty fresh, right? And so it hasn't had a lot of exposure to sunlight, and the microbes haven't had that much opportunity to die. So if you measure up there, then I think for sure. But if you're measuring on the IB pier, for example, there have been proposals, or I know I've heard about sort of things on the IB pier to do this sort of stuff. You're not going to see any pathogens. You're not going to see any pathogens if you're looking for E. coli or enterococci as during the summertime southwell seasons if the river's not flowing. So up the source, yes, I think that would be a big help.
Thanks.
Notice, you guys should, if you haven't already had, should have Amy Zimmer-Faust from SQUIRP, the Southern California Coastal Water Research Program, to present to you guys about the work that she and her group did, where during south swells what they did is they went to, they basically took water samples all along here, and they did standard sort of like InterAlert type stuff, but what they also did is all these, quantitative PCR and DNA marker type things, type stuff. And basically they were able to see that the south swell was bringing pathogens and these markers up north. But as was expected, the InterAlert wasn't really seeing it because those things were dying. The enterococci were dying.
Yeah, we're in contact with SQUIRP on similar subjects. So thanks a lot. Great presentation again. And I'll follow up with an email. Thanks.
Okay, our last question comes from Artie.
Hi, thank you. So this is Artie. I'm representing Marin County here. Great presentation. I have a question about the QMRA and the microbial modeling that you did it here.
Yep.
So my first question is about the norovirus. What was the concentration of norovirus that you used it in your modeling? And then the second question I have here is die-off rate of norovirus. Did you consider the die-off norovirus in your QMRA modeling when you run this model? Thank you.
Yes. So I'll answer the first question first. When you look here and you see these plumes here that are going to the thing, these plumes are actually also decaying with the half-life that's appropriate for norovirus. But it's a 14-day half-life, so it's relatively slow. But if you were to watch this plume, it would over time it it would decay. And so I can't remember the exact numerical value. It's given in our paper, and the source of it is given in our paper. There's a meta study of norovirus in raw sewage, and we used their median value.
Thank you.
There is also I actually misspoke. There is a distribution with a mean and sort of like basically a log normal distribution,
Right.
a log normal mean and standard deviation. When we did the QMRA, we did the QMRAs over the range of potential source norovirus concentrations, so that it was sort of like an ensemble average.
I see.
Yeah.
Okay. Thank you.
Mm-hmm.
That's it for our questions. If you'd like to follow up with Falk, please put them in the chat if you have time, Falk.
Could I answer? Someone had asked a question sort of like about the catastrophic infrastructure failures and stuff like that, and I never got a chance to respond. But like this table here makes a pretty strong case, and I'll just highlight two. So this goes by October of 2016 to October 2017, in all these years here. And basically, it looks at what the flow rate is, because there's a gauge, so we know what the flow rate is into the estuary. And in the wet season of the October 2016 to April of 2017, there was a lot of flow into the Tijuana River estuary. It was flowing a lot of the time. And then some winters are very dry, and this winter also had infrastructure problems and was very wet. Some winters are relatively dry without infrastructure problems. 2019, 2020 was both wet and had a lot of infrastructure problems, so there's a lot of flow into the estuary. We can also look at the dry season, and this is telling. In 2016, the summer of 2017, there's almost no flow into the estuary, and this is why our results say that Punta Bandera is the most significant source of swimmer illness, because most swimmers are in the summertime, and these plumes don't dilute very rapidly, and the norovirus doesn't like to decay, right? And in other years, it's also pretty low. But this year, the summer of 2020 is when there was 11 million gallons a day constantly, essentially 85% of the time, flowing into the estuary. And this is because basically the bypass system to the International Wastewater Treatment Plant was broken. And so raw sewage is constantly flowing in. And if we had simulated this year, this summer here, almost certainly this 11 million gallons a day coming in right here at the mouth of the estuary would have dominated over the 35 million gallons a day coming from Punta Bandera, right? But the overall conclusions of which scenario is the best is still correct, because if it's 11 million gallons a day, that's a much, much less than the 35 million gallons a day or the 50 or 60 million gallons a day that the EPA, I believe, is proposing to take out from the Tijuana River estuary. So basically, you would fix this problem with a 35 million gallon or 50 or 60 million gallon diversion, and you would fix the Punta Bandera problem by, in some sort of way. And then for sure in the summertime here at IB and along all the stretch of the coast, swimmers are going to be happy. And that's all I have to say. Thank you.
Great conclusion. Thank you so much for sharing, and kudos to you and your team. Fantastic stuff.
Thank you.
Thanks.
Thank you.